Hi, good morning everyone. Welcome to Unacademy, India's largest learning platform. This is Shefali Singla, and in today's session we will be discussing about dynamic multi-level indexing. That is nothing but B tree and B plus tree. In yesterday's session we had discussed the disadvantages with static multi-level indexing, and we had solved few questions on the basis of indexing. I just hope that there is no doubt in the concept that we have already discussed. B tree and B plus tree is, especially the B plus tree concept is very important. From the past 6 to 7 years, every year question is being asked on the basis of B plus tree. Okay, so this is gonna be a very interesting session, and on the basis of this, file organization, whatever questions have been asked in the GATE exam, that we will be covering in today's special class. Each and every question will be discussed in detail, but in today's special class, in this session, we will be just learning the concepts and the properties and how to construct the tree, etc. etc. And to follow the special class, you have to download the Unacademy Learning app. This app is available on both the Play Store and the Apple Store. So by downloading this app, you can follow the educators, and also you can access the lectures, you can participate in the live tests, quizzes, discussion, etc. But make sure that when you are downloading the app, it's the correct one, because two Unacademy apps are available. One is the Unacademy Learning app, which is for the learners, and to follow any session, you have to unlock the free plan, like free lectures. If you want to follow, you need to apply the referral code which is displayed on the screen, that is Shefali, Shefali. If you are targeting on GATE 2022 or 2023, then you can go for the subscription, so that the 100% syllabus will be covered in detail, along with the weekly quizzes, and material will be provided to you, and set of practice sessions, practice questions will also be provided to you. So in the under the subscription plan, we have two types of subscription: plus subscription and the iconic. Plus is our basic plan to get started with, and iconic takes your preparation level to the next level with the help of personal coach. If I talk about the common benefits of plus and iconic, first of all, in both the plans, you will be able to access unlimited interactive live sessions. You can follow any number of educators. That is one benefit. Second one is, for each and every session, structured courses and PDFs will be provided to you, along with the live tests and quizzes. Okay, so this is the benefit, and apart from this, in the iconic subscription, you will be getting a guidance from the mentor, that is the personal coach. Personalized test analysis will be done. Study planner is also included, along with the preparatory study material. And this preparatory study material also contains the set of practice problems. So this is the difference between plus and the iconic. For your convenience purpose, all these benefits are mentioned in the description box. So just go through it once if you have any doubt, or you can get in touch with our team. And under iconic, we have two types of plans: 1 year and 2 year. 1 year plan is for 50,250, and 2 year plan is for 74,000. If you are going to apply this referral code, then you will be getting 10% discount. So for 1 year, you have to pay 45,225, and for 2 years, you have to pay 66,600. If you look at the difference, so here the duration gets doubled, but fees may approximately 21,000 ka difference are. So what are the additional benefits? First of all, let me tell you that this 2 year plan is beneficial for the students, those who are going to start their preparation at the early stage, like when you are in the second year or third year. First year end hone wala hai aapka, so already first semester is over, so you can also start it from the second semester. With this, what will happen? By the end of third year, as you know that third year students are also eligible for writing the GATE paper. So third year, by the end of third year, you can give your 100%, and you can write the GATE paper. Second thing is, whatever subjects we are going to cover under the GATE's preparation, those are the core technical subjects which are included in the university curriculum, and majorly those are the subjects which are taught in the second year and third year. That means third semester, fourth semester, fifth and sixth semester. तो सेमेस्टर बाय सेमेस्टर जब आप अप टू द गेट लेवल सब्जेक्ट को प्रिपेयर कर लोगे, तो आप पे एकदम से बर्डन नहीं आता है. एंड मोर ओवर, you need not to worry about the semester exams, because if thoroughly you have covered that subject in detail, then easily you can score well in the semester exam without going for subject wise coaching or without putting in extra efforts. And next benefit is you can improve your gate score. Third year ke baad fourth year, anyhow you have to complete your degree. So in the fourth year, again you can give your 100% to get the good marks. And in case if you want to improve further, you want to improve your gate score, then you will be having one more chance without dropping an year. So this way it will help you to improve your gate score. And moreover, when you'll have more time for practice, so definitely you will get a good score. And the third benefit is for the students, those who are interested in the campus placements. This means that you have to go through the various rounds, like the elimination round, in which you can expect the multiple choice questions from technical and the non-technical portion. Some companies do conduct their coding round, and definitely the technical interview will be there. Now, in this case, what all subjects are important from placements point of view, that is data structures and programming, algorithms, DBMS. Along with this, you can expect the multiple choice questions from operating systems, computer networks and non-technical portion. If you look at the important subjects, these all subjects are the part of the GATE syllabus. So if you have covered these subjects, तो placements के लिए आपको और ज़्यादा efforts डालने की ज़रूरत नहीं पड़ेगी. Additional efforts बच्चे आपके बहुत कम हो जाते हैं. And fourth benefit is for the students, those who are targeting on PSUs, as many of the PSUs are directly recruiting on the basis of GATE score. And if they conduct their own paper, then majority of the syllabus is the GATE syllabus. And in fact, you can expect the previous year GATE questions directly in the PSUs. So that is the benefit of preparing the GATE exam. And 1 year subscription is beneficial for the students, those who are in the fourth year or those are pass outs. So see which plan suits you better. And whenever you want to start your preparation, it's always good to start your preparation as early as possible. Next, in case if you want to get the plus subscription, then we have different plans like 1 month, 3 months, 6 months, 12 months, 1.5 year and 2 year plan. 1 month, 3 months and 6 months is for those students, those who want to cover few subjects in detail, or those who want to join or get the subscription for a crash course purpose. So for that, according to your convenience, you can opt for either of the plan. Hi, good morning, Harsha. And if in case you want to cover the 100% syllabus in detail, then at least go for 1 year subscription. 1 year plus subscription is for 27,225. 18 months is for 34,650 and 2 year subscription is for 39,600. This is the fee structure after applying the referral code, because actually these are the fees, and but if you are going to apply the referral code, you will be getting 10% discount. So after the discount, this is the fee that you have to pay. Hi, good morning, Lalit. So I hope that it's clear to everyone. And if you want to get to know more, then you can fill out the feedback form, and the form link is given in the description box, and definitely our team will get in touch with you. So let's crack it. Are you ready? Very, very important, very interesting topic. Generally, students do go for cramming the formulas. Don't do that. I'll discuss the structure, and on the basis of that, easily you can determine the formula. Okay? Fine. So, first of all, why we are going for the concept of dynamic multi-level indexing? In yesterday's session, we had discussed the drawbacks of static multi-level indexing. So, the drawbacks were like if you are going to insert or delete some data from the multi-level index, then it results in changing the entire index file. Good morning, Dharmendra. Right? If you don't want to change the file, then you are going for the overflow pages. Then also it is creating the problem. And in the case of deletion, sometimes whole data is deleted, then the block is empty. It does not ensures that how much data needs to be occupied. So in order to overcome all these drawbacks, we are going for the concept of dynamic multi-level indexing. So the goals of dynamic multi-level indexing are to overcome all those drawbacks. That is, insertion or deletion should not result in entire index change. Which was happening with the case of static multi-level indexing. Second goal is no overflow pages should be there. No overflow pages should be there. And third one is every index block should ensure some occupancy. Every index block, but we can't put this constraint on the root, except the root should be at least 50% occupied. So these are the goals of going for the concept of dynamic multi-level indexing, because these were the drawback with the static multi-level indexing. So in order to achieve these goals, we use whatever is the topic. So we use the following one, that is the multi-level indexes. This is B tree and B plus tree. Why there are two different dynamic multi-level indexes? First of all, the concept of B tree came, but there was some problem with the B tree, because in this case, if you want to access the data sequentially, that was not supported. So in B tree, only random access is allowed, whereas in case of B plus tree, random as well as sequential access is allowed. So that is the basic difference between B tree and B plus tree. So obviously, when it has to achieve the property of sequential access, then there will be a change in the structure of the node. Let me discuss the difference. Difference between B tree and B plus tree. So first of all, whenever tree is pointing to the other nodes, those pointers are known as the block pointers, and when it is holding some value, that is known as the key value, right? In case of B tree node, obviously in any tree we will be having the leaf nodes. We will be having the leaf nodes or the internal nodes. Similarly, in case of B plus tree also, here I will be writing the points about the B tree and B plus tree. First of all, let's understand the difference, and then the question is basically asked on the structure or some numerical type. They may give you the size of the key and the pointers, and they'll say that what is the minimum number of pointers or what will be the order of the tree. Okay, so first of all, if I talk about the performance, B tree is used for random access only. If I talk about the performance, B tree is used for random access only, but B plus tree is used for both random and sequential access. Random and sequential access. So if I talk about the structure of the leaf node, so in the leaf node, there are only the keys and the record pointers. Only keys and record pointers are there. Whereas in case of B plus tree, here we have the keys plus record pointers. I'll let you know how to construct this. Record pointers and one block pointer. One block pointer. But there's a major difference between the internal node, because in the internal node, in the B tree, it will be having the key, it will be having the block pointers, and also it will be having the record pointers. And record pointers are present. Whereas in case of B plus tree, internal node only contains the keys or the block pointers. अभी don't get confused. अभी आपको ये लग रहा होगा what is record pointer, block pointer, key. Let me discuss this. Again, we'll come back to this slide where the differences are written for your purpose, for your convenience. Okay. So first of all, let's talk about what is this B tree or B plus tree. So B tree is, or B plus tree is nothing but this is also known as multi-way search tree. Let's start our discussion with the B tree first. B tree, this is also known as multi-way search tree as well, and definitely it supports the concept of dynamic multi-level indexing. Multi-way search tree. First of all, in the exam you will be given with the order of the tree. What is this order? Order of a tree, if it's given, so basically it depends on, this is giving you the idea that in a tree how many block pointers are possible. Block pointers are possible. Maximum number of block pointers. Sometimes they can change the definition. They may consider that the order of a tree is nothing but it depends on the number of keys, maximum number of keys that a node of a tree can hold. Okay, so maximum number of block pointers in a B tree. For example, if I'm saying that the order of a tree is P, order of a tree is P, and you are given that P is equal to 3. Order of a tree is given as 3. So this means that, let's consider one node. Block pointer means which is pointing to the next block, and record pointer is where it is pointing to a particular record in the database file. Okay, so is the difference clear that what is the block pointer and the record pointer? Block pointer is pointing to the next block. Next block means the next node, and record pointer is pointing to a record in the database file. So if order of a P is nothing but it's the number of block pointers, and here we are saying that this is having 3 block pointers. Let's say this is one block pointer, this is second block pointer, this is the third block pointer. This is block pointer 1, this is pointing to next node. This is another block pointer. This is the third block pointer. So if 3 block pointers are possible, then how many keys you can store? One key will be stored here. Let me call this as K1. This is the another key. So only 2 possibilities are there. And if it's a B tree, then with every key there is a record pointer. There is a record pointer. If I am assuming that, if I take that the order of a tree is given as 4, so order of a tree means that maximum number of children. Maximum number of block pointers is nothing but the maximum number of children. This node can have how many children? 3 children. If we are saying that the order of a tree is given as 4, it's given as 4, this means that 4 block pointers are possible. So this means that this node can have how many children? It points to block 1, this will point to block 2, this will point to block 3, this will point to block 4. Key 1, record 1, key 2, record 2, record pointer 2, key 3 and record pointer 3. So it's very much clear that if order is given, this means that it can have maximum number of children. That is, maximum children कितने होंगे? That is equal to P. Maximum children or maximum number of block pointers is P. Then what will be the maximum number of keys that a node can hold? Maximum number of keys, it will be P minus 1. If the block pointers are 3, then it can hold 2 keys. If it's 4, then it can hold 3 keys. If it will be 5, it will be holding 4 keys and so on. So maximum number of keys are P minus 1. But we are saying that multi-level indexing, dynamic multi-level indexing B tree or B plus tree ensures at least 50% occupancy. At least or minimum wala case कब consider करते हैं? When we are going for the deletion of the elements from the B tree or B plus tree. So according to 50% occupancy, what will be the minimum number of children for any node? If maximum children are P, then minimum children will be how much? It will be P by 2. Ma'am, if P is given as some odd number, so let's assume that P is given as 7. So 7 divided by 2 is 3.5. So in that case, do we need to take the flow value or the seal value? They're saying that at least 50% occupancy should be ensured. 50% से कम नहीं हो सकता. P by 2 is fine. So if order is 7, can I take 3? If I'll be taking 3, it won't ensure 50% occupancy. So this means that if I'll be taking flow value, in that case, it will not ensure 50% occupancy. 3.5 to minimum value है. इसके ऊपर anything is allowed but not less than that. So this means that we need to take the seal value. Is this clear? Yes. Then in that case, we need to take 4. यहाँ तक clear है? If these are the minimum number of children is nothing but the minimum number of block pointers. If these are the minimum number of block pointers, then what will be the minimum number of keys? Then what will be the minimum number of keys? Keys are 1 less than the block pointers. So it will be P by 2 minus 1. Maximum case we have to consider, maximum condition we have to consider when we are inserting the elements in the tree, and when you are deleting the elements at that point of time, you have to consider the minimum condition. Yes? So in this case, what will be the maximum number of block pointers? It will be 3. Maximum keys will be 2. Minimum number of children or block pointers, it will be 3 divided by 2. 3 divided by 2 means we have to take its seal value, that comes out to be 2, and minimum keys in a node should be equal to 1. 2 minus 1 is 1. I hope that till this point it's clear. Yes? Now, we have to determine the formula. So, we know that if the node is the internal node, structure of the nodes, structure of the nodes for B tree and B plus tree. Understand this structure very carefully, because on the basis of this I'll be deriving the formulas जो आप लोग cram करते हो. So if the order is P, order of a tree is given as P. First of all, let's talk about the internal node and leaf node. order is P, this means that P block pointers will be there. One block pointer 2, block pointer 3, block pointer 4, block pointer, and so on. Here we have P block pointer. Similarly, if we have the leaf node, let us consider the structure. Order is P. This is block pointer 1. This is block pointer 2. This is block pointer 3. This is block pointer 4. And this is block pointer P. Because P block pointers are possible. Now, how many keys are possible? It will be, let's assume, key 1, R1. With every key, there is a record pointer. Record pointer ये बताएगा कि that particular key is stored where in the database. So we have here key 3, R3, and so on. So here we have P minus 1 and record pointer P minus 1. Now this one node should fit in the one block, right? This should fit in the one block. If it's the internal node, definitely it will be having the block pointers. If it's a leaf node, definitely these block pointers will be null. Leaf node means it does not have any child. Then all the block pointers will be null. Block pointer 1, block pointer 2, block pointer 3, and so on. Key 1, record 1, key 2, record 2, key 3, record 3, and so on. So what will be the structure? What will be the formula? Block के अंदर, in the internal node, block pointers, record pointers, and keys are present. If the order is P, then in one block, ma'am, today any special class? Definitely today we will be having the special class on the PYQs of file organization. जो कल वाला topic था और जो आज topic खत्म होगा उसके basis पे we will be discussing all the previous year questions. Okay. Now look at the structure of internal node. How many block pointers are there? P block pointers. Number of keys? P minus 1 keys. Plus, what else is present in this node? In this block, it's P minus 1 record pointers. Where P is, I'm writing this for block pointer. And I'm writing this RP is for record pointer. And all of this data should present is पूरे का size. It should not exceed the size of the block. So this is one formula based on the structure of the internal node of B tree. Similarly, in the leaf node, what will happen? In this case, it just have these all block pointers does not exist, so it just have P minus 1 keys and P minus 1 record pointers. And one more thing, since it's a multi-way search tree, so whatever values will be present here in the child of this one, what will be those values? All should be less than what if X values are present. So all these values should be less than K1. If it's present on the right hand side, what will be the values? It must be, these children must be greater than K1, but smaller than K2. This means that whatever values you are having in the node, it should be in the sorted order, and moreover it should be smaller than, if the values are present in the left side, it should be smaller, and if it's greater, then it will be in the right side. Correct? So if I have to find out the children in the block 3, if the elements are x, so all these elements should be greater than k2 and should be less than k3. This is another point. Any doubt in the structure of a node or this property? This is the basic, and on the basis of this, so this is one point, this is another point. Third point that I have discussed is all the values, all the keys of a node should be in the ascending order. Third point is keys within the node should be in ascending order. This means that if the keys are K1, K1 should be less than K2, should be less than K3, and so on up to K minus P minus 1. X means some value, some key value, that is X. For example, what do I mean by this point? If I'm saying that a node of a B tree is containing the elements something like 4, 3 and 6. Is this allowed? Here, this is key 1, this is key 2, this is key 3. Are they in the ascending order? This is not in the ascending order, so this is what? This is invalid. What will be the valid order? It must be, doesn't matter in which order they are inserted, but it must be in the ascending order. This is a valid node. So the keys within the node should be in the ascending order. Next point, every internal node except root should be, there must be at least 50% occupancy, should have these many block pointers. Why we are taking the seal value, I hope that that is clear. These many block pointers are must, and maximum how many block pointers are possible? It depends on the order of the tree. So at most P block pointers should be there. But there is an exception for the root node, because sometimes whenever you are creating a root, going for the node splitting, only one element is present. So, but for root, except for root. In case of root, minimum block pointers are 2 and maximum are P block pointers. So let me write this point here. Root can have at least 2 block pointers and at most P block pointers. And other important point is, in case of B tree and B plus tree, all the leaf nodes will be at the same level. All the leaf nodes will be at the same level. So these are the main points. I hope that this is clear to everyone. Now we'll first of all look at the construction of the B tree, and then we'll look at the deletion. Ma'am, fifth point, please repeat. Root can have at least 2 block pointers and maximum P block pointers. Maximum to P ही आएंगे. I'm going to take the example at that point of time, जो अभी next question में ले रही हूँ, उसमें I'll explain this concept. Okay? Alright? So let's consider the construction of B tree from the given set of elements. So consider the following elements, and we have to construct construct B tree, and the order of B tree, order can also be known as the degree, तो आप degree भी बोल सकते हो, B tree with degree 3, and we have to construct a B tree with degree 3, and the elements are something like 5, 10, 12, 13, 14, 1, 2, 3, 4, something like this. Okay, so first of all what we'll do is we'll take the first element. Node can have 3 block pointers. This means that in a node you can store 2 keys. Maximum number of keys in a node can be, maximum number of keys in a node will be equal to 2. So first key is coming up, that is 5. So 5 will be inserted. Next 10 is coming up, 1 empty slot is there, 10 is added. Now 12 is coming up. When 12 is coming up, this is a case of overflow. Whenever there is a case of overflow, in that case we'll go for the concept of node splitting. Node splitting. Node splitting means node divide हो जाएगी, क्योंकि अब इस एक node में all the elements you cannot fit, cannot insert, right? So node splitting will be done on the basis of the middle key, because anyhow this will be a binary, kind of a binary search tree, but here it's not binary, it's a multi-way search tree, right? So which node, on the basis of which node it will be splitted, you are having the elements 10, 12, so middle one is 10, so it will go up. So after the node splitting, it will look like 10 is splitted. This is the structure of a node. So split होके 10 goes above to the next level. This block pointer is pointing to other node. So what will be the elements here? 10 goes to the root level. Sorry, this is 10. And 5 will be present in the left child, and right, on the right side we have 12. Now take the next element. Can I insert it here? 13 is coming up, so it will be compared with the root. 13 is greater than 10, so go to the right block pointer. In this, where this 13 will come here. Next, take the next element 14. 14 is we want to insert 14 here, but this is a case of overflow. Now again, what will happen if it's a case of overflow? Again, the node will be splitted. 12, 13 and 14, node will be splitted on the basis of what? On the basis of 13. So now this looks like there is no change in this node. बेटा यहाँ पे मैं properly notes बना रही हूँ. Next question onwards we won't be obviously you know that block pointers you have to take. Okay, so what will be the elements here? 10 remains as it is. 13 is going up. On the left of 13 we have 12, and on the right of 13, I'm so sorry, on the right of 13 we will be having one more node. Here it will be pointing to 10 के left में कोई change नहीं है as it is. 13 के left में we have 12, and on the right we have 14. Okay, next 1. Next we have to insert 1. 1 will be inserted where? In this tree. Now in this case, can I add 1 here? After 5? It's not possible. Insert leaf node में होगा plus parent node के साथ compare होगा, right? First of all, you have to compare. Whenever you have to insert any element, always the comparison is done with the parent node. So I want to insert 1. 1 is greater than 10 or less than? Less than 10, so it will go to the left child. In the left child, 1 empty slot is there. So can I add it after 1? If I'll add it 1, then it won't be in the ascending order. So here we will be having the 1 and here it will be 5. Now, in the next case, we are getting the element 2. If I try to insert 2 here, this comes out to be 1, 2, 5, which is not possible. So this means that we need to go for the node splitting. Now, when 2 will go up, so here it comes out to be 2, 10 and 13. Again, it's a case of overflow. Again, there is a case of node splitting. But sometimes what happens is they do consider the concept of redistribution. Key redistribution. After adding the element 2, what will be the resultant tree? So this will look like 10 will go up. On the left of 10, we have 2. On the right of 10, we have 13. And on the left of 2, we have 1. On the right, we have 5. And on the left of 13, we have 12. And on the right, we have 14. Ma'am, 10 और 13 दोनों के साथ होगा. See, when here you are trying to insert 2, let me repeat this point. When you are trying to insert the element here, you got the position कि 2 कौन सी node में आएगा. 2 is smaller than 10, so 2 will be added here. So it comes out to be 1, 2, 5, which is a case of overflow. If it's a case of overflow, then node splitting will take place. Node splitting will be done on the basis of the middle element. Middle element is 2. So 2 is going above. So when 2 is coming here, on the left of 2 we have 1 and on the right of 2 we have 5. That's fine. But when 2 you are trying to insert here, 2, 10, 13, 3 keys are possible in one node. Are these possible? This is not possible. So this means that at the parent level also node splitting is going to take place. 2, 10 and 13, this is a case of overflow. So what will happen? This 10 will go up. From this level, one more level is created. 10 is going up and on the left of 10 we have 2 and on the right of 10 we have 13. Now is this clear? Is this clear? I'll be taking more examples with the more order. This is the first example. In this case, I have taken the order as odd. तो आपके पास middle element एक ही आ रहा है. Our next example will be based on the even order. Okay, let me finish this example. Dharmendra is saying that please repeat. From which point you want me to repeat, Dharmendra? बेटा यहाँ पे आपको एलिमेंट कहाँ पे ऐड करना है. 2 कहाँ पे ऐड होगा? 2 is compared with the root node. It goes to the left. On the left side, already all the keys are full. So this is nothing but this is a case of overflow. 1, 2, 5. This is the ascending order. तो splitting किसके basis पे होगी? 2 के basis पे. 2 leaf level से कहाँ पे चला गया? Internal level पे. When you are trying to insert 2 here, again this is a case of overflow. Again the node splitting will take place. Now is this clear? Now 10 is inserted here. After this, I'll introduce the concept of redistribution as well. Just let's get comfortable with this concept first. Now, I want to insert the next element, that is 3. 3 will be compared with the root node. 3 is smaller, go to the left side. 3 is greater, so go to the right side. So 3 will be inserted here on the right of 5. In one node, you can have 2 keys. So 3 and 5 is there. Correct? Next, I want to insert the node 4. 4 is less than 10. 4 is greater than 2. So 4 needs to be inserted here. 3, 4, 5. This is a case of overflow. So 4 will go up. So this comes out to be 10. And on the left of 10, we have one node in which only one key is present. And on the right hand side of 10, now 4 is coming up. 4. And node is 13 here. This is pointing to a node which is having one child. And this is going to point just one key is present. Here the key 5 is present. 12. And here its right pointer is pointing to a key with the value 40. So finally, this is the B tree with the order 2. Okay? But in case if they are asking for the minimum number of node splittings, in that case you have to go for the concept of key redistribution. This means that before splitting the node, you need to check if that node is adjusted by its sibling or not. Immediate sibling pe check karna, not on any other sibling. Okay, let's take the same example with the key redistribution, or let me take it here only. In this case, first time when the node splitting, it does not have any sibling, so the node splitting was taking place. Then when 14 ke time pe it got splitted, instead of going for the splitting, you could have gone for the concept of key redistribution. Redistribution means again redistribute the keys. So in this case, what will happen? This node is in problem, overflow hai, problem hai. तो किससे help मांगेगा? It will ask the help from its sibling. Do you have the space to adjust the key? He'll say that yes. So what will happen? Can you directly send 12 here? No. So 12 will go at the parent's level and parent will come down. So according to key redistribution, what will happen? Here 12 will go up. Here we'll have 5 and 10. And on the right hand side, now 13 and 14 can be adjusted. 13 and 14 is adjusted. In previous case, what was happening? Node was splitted. Here, node is not splitted. So in the exam, if they are asking for the minimum number of node splittings, then you have to consider the concept of key redistribution. Ma'am and gate also need to draw the whole tree. पहली चीज बेटा insertions के ऊपर questions कम आए हैं. If they are asking the question, then you have to construct the tree. Any doubt till this point? यहाँ तक clear है concept? Okay. Don't worry about the previous year questions. Gate में किस type के questions आते हैं? I'll be discussing each and every type of question in the class. So don't worry about that. अभी के लिए बेटा कॉन्सेप्ट पे फोकस कर लो, PYQs भी कर लेंगे हम. So this is how the nodes can be inserted in a tree. Now let's take one more example where the order is even. Okay, with the even case. One more point I have to discuss. This is the final B tree. If you observe here, if you have to access any node, is there any sequential order? कोई sequential सारी की सारी nodes leaf level पे नहीं मिल रही हैं. This is not pointing to the next node, so you have to go through the different levels. So that is nothing but the case of the random access. This problem will be overcome in case of B plus tree. Now let's construct B tree with the order 4. Construct B tree with order P is 4 and the elements are given as 5, 10, 15, 20, 7, 1, 3, 12, 28 and 18. So if order P is given as 4, this means that maximum block pointers are 4. And what will be the maximum keys? In a node, how many maximum keys can be there? Keys क्या होती हैं? Maximum block pointers, ठीक है, एक node में कितनी keys आ सकती हैं? Yes, it will be 3. So let's insert the elements. अब मैं properly वैसे block diagram नहीं बना रही हूँ. So here, first of all, 5 is inserted. Then 10 is coming up. Second key. 15 is coming up. कोई problem नहीं है. Now what is happening? 20 also wants to add in this node. This is a case of overflow. This is a case of overflow. So the splitting is done on the basis of the middle element. So we have the elements like 5, 10, 15 and 20. Now question arises is whether this 10 will go up or 15 will go up. So in this case, anything can go up. It depends whether you are working on right biasing or left biasing. Left biasing and right biasing. Left biasing means in the left node more number of children will be there, because when we'll talk about the children, one node is going up. So in one node we will be having one node and in another node we will be having two nodes. So if it's a case of left biasing, so 15 will go up and on the left of 15 we will be having 5 and 10. And if and here we will be having 20. This is a case of left biasing. And what is the other possibility? That is right biasing. So in case of right biasing, 10 will go up. Here we'll be having 5 and 15 and 20. Both are correct. You can go for either of the method. You can go for either of the. Left biasing means more number of elements are present in the left node. Right biasing means more number of elements are present in the right node. But किसी भी केस में ऐसा नहीं करना, किसी एक टाइम पे when you were splitting the node, then you are considering left biasing and the next step you are considering right biasing. Don't do that. If you are working on left biasing, then work on left biasing. If you are using right biasing, then use right biasing only. Alright. So let's consider, let's assume that we are using the concept of right biasing. So let's construct the tree. Yes, need to follow one particular order. If we are going for right biasing, then 10 will go up. Here we have 5 and it will be pointing to 15 and 20. Basic structure आपको मालूम है, right? How to draw that. So it's having the block pointers. Just to quickly discuss, I'm drawing it like this. Alright. Now 20 is inserted, next is 7. 7 is smaller than 10, go to the right side. 7 will be added where? After 5. No issues. This is not a case of overflow. Now I want to insert 1. 1 will be added where? Before 5. 1. It is also inserted. Now 3 is coming up. So it comes out to be 1, 3, 5, 7. This is a case of overflow. So the node splitting will take place. Now again, it depends if they are asking about the minimum number of node splittings, then you have to consider the concept of redistribution, right? If nothing is said, then also, then in that case, you can go for any method. So in this case, 3 will go up according to right biasing. So here at the root, we will be having, okay, Shweta asked one question, कि root पे कैसे exception है. If you look here, when first time node splitting is taking place, तो obvious सी बात है बच्चे, एक ही element root पे जाएगा, right? First time when the node splitting is taking place, only one element will be going to the root. So in that case, it is not able to satisfy the 50% occupancy constraint. So that is why we have said that there is an exception for the root node. Correct? Now 3 is going up. Here we have 10. And there is a block pointer, there is a block pointer, there is a block pointer. There is no change in the string. Here we are having on the left of 1, on the left of 3 we just have 1, and on the right of 3 we have 5 and 7. So 3 is also inserted, take 12. 12 will go where? Compare it with the root node. It's greater than 10, so go to the right side. So 12 will be added where? Between this? No, it should be added before. It becomes like 12, 15 and 20. First of all, it will be given in the question. Second thing, बच्चे ऐसे ambiguity वाले कोई questions नहीं आएंगे. अगर आ जाता है तो definitely you have to consider, और सिर्फ आपको tree देख के समझ में आ जाएगा which method you have to follow. 12 is inserted, next is 28. 28 will be inserted where? To the right of 10. So 28, this is a case of overflow. So which node will go up? That is 15. So here we'll get 3, 10 and 15. This node was splitted. So on the right, on the left of 15, we just have 12. And on the right, we have 20 and 28. Next, remaining tree remains as it is. So here we have 5 and 7. And here we have 1. बेटा मैंने पूरा स्ट्रक्चर ड्रॉ नहीं किया. हर एक नोड का जो स्ट्रक्चर है, that is the same. In every node, you can store 3 keys. I'm doing this just to save the time. Okay, here also you can store 3 keys. So this is inserted. Take the next element, 18. 18 is greater than 15, so it will go to this side. So here it comes out to be 18, 20 and 28. So this is the tree. This is the B tree. Chatterjee asked this question, what if the order is given as 4? So if even order is given, then you have to consider whether it's working on right biasing or left biasing. Then you can opt for any element. Is this clear? Or you want me to take more questions on the basis of this? Otherwise, we'll generalize this concept. So as of now, we have constructed the B tree. We have discussed the construction of B tree with even order, odd order. We have discussed the concept of left biasing, right biasing, node splitting and key redistribution. Summary bana do khali. So what we are saying, in case of insertion, whenever we are adding the elements, first of all you need to find out the correct position. Find out correct position, because all the keys are in the ascending order, so it's just behaving like a binary search tree. May you just have two child for a node, but in this case it depends on the order of the tree. Find out the correct position of the element and see after adding the element if it's a case of overflow. If it's a case of overflow, then there are two ways. One is to split the node splitting, and second one is node splitting, and second case is the key redistribution. Key redistribution method must be followed in case if they are asking for the minimum number of splittings. And whenever you are going for node splitting, then we have the scenario if the order is even or odd. If the order is odd, then just splitting will be done on the basis of the middle element, and if the order is even, then in that case we have to consider whether it's a case of left biasing or it's a case of right biasing. So this is all what we have discussed. And apart from that, we have discussed the structure of the B tree node, leaf node and the internal node. Right? Chatterjee's focus is always on the summary only. Is this clear? So this is all about the insertion in the B tree. Redistribution ऐसा नहीं है कि पड़ोसी से next जाना है, so it will just look for the sibling only. Let's quickly take one more example and then we'll summarize the insertion. We'll wind up with the insertion in the B tree. Then we'll go for the deletion. So in this case, the degree is given as 5. And you have to insert the elements 5, 10, 12, 13, 14, 1, 2, 4, 20, 18, 19, 17, 16, 15, 25, 23, 24, 22, 21 और एलिमेंट्स ऐड करने हैं, बहुत है. बहुत है. Sufficient. All right. Now, construct the B tree. You have to construct the B tree. Degree is 5. This means that in a node, maximum number of keys, how many keys are allowed? Maximum keys allowed are 4. 5, 10, 12, 13 कोई problem नहीं है. 5, 10, 12, 13. There is no problem. When 14 is coming up, that's a case of overflow. So which node will be splitted? 5, 10, 12, 13, 14. So 12 will go up. 12 will go up. So this will result into, we have 12 here, 5, 10, and on the right hand side we have 13 and 14. Next, insert the next element, that is 14 is also inserted, that is 1. 1 will be added where? 1 is smaller than 12, so it will be added to the left tree. 2 is smaller, 2 will be added here. 4 is smaller, so it goes to the left tree. This comes out to be 1, 2, 4, 5, 10. It's a case of overflow, so 4 will go up. अगर की redistribution use करना है with the node splitting, what will happen? It comes out to be 4, 12. Here we have 1 and 2. Here we have 5 and 10. And in this tree we have 13 and 14. This is with node splitting. I have used node splitting here. What if I have to use key redistribution? Key redistribution. Then what will happen? In that case, it won't split the node. It will ask its sibling, can you help me out? 1, 2, 4, 5, 10. This node is going through overflow case. So it will ask its sibling, can you help me out? Can you adjust one key? It will say, yes, I have the sufficient space. So what will happen? Directly this 10 cannot move here. Because 12 ke right pe 10 is not possible. So 12 will join the right subtree and 10 will go up. In that case, here we had 3 nodes. So in this case, what will happen? 10 will go up. This will go to the next position. And 12 is adjusted in the right subtree. 12, 13 and 14. And on the left, we have 1, 2, 4, 5. 3 nodes were there. Now also 3 nodes are there. Node is not splitted. So this is how it is going for a key redistribution. दोनों differences clear है? Now insert the next node. Repeat the step. बेटा की रीडिस्ट्रीब्यूशन का क्या मतलब है कि कीज को रीडिस्ट्रीब्यूट कर दो, दोबारा से एडजस्ट कर दो, स्प्लिटिंग नहीं करनी है. This is what I have explained, that if they are asking for minimum number of node splittings, then you have to go for the concept of key redistribution. So in this case, what will happen? Obviously बात है, जब आप कोई गड़बड़ कर देते हो तो आप किसकी हेल्प लेते हो? You ask your sibling, can you save me? If he is ready to help, if it's in the hands of your sibling, so definitely he or she will help, right? So in this case, it is asking the sibling, can you adjust one key? Ma'am, exam में different method पे भी question आएंगे. Different method as in? बेटा आप लोग point ही नहीं सुन रहे हो. Key redistribution is used whenever in the question they are asking for to construct the tree with the given set of elements or with the minimum number of splittings. Minimum number of node splittings. Or minimum number of levels. In order to construct a tree, B tree with these many elements, what will be the minimum number of levels of the B tree? Minimum number of levels. अगर minimum levels पूछे, minimum number of node splittings पूछे, something like this, then you have to use the concept of key redistribution. So it depends on the question, what they are asking in the question. You can either go for node splitting or key redistribution. Why 10 is going at the root? Minimum is strict for key distribution. Yes. If minimum is, you can observe here, अगर redistribute हो रहे, definitely it is not going to the next level. Splitting नहीं हो रही है, तो minimum number of levels will be there, right? Now, if directly, okay, you are saying कि 10 के ऊपर जा रहा है, अगर यहाँ पे बचे 1, 2, 4, 5, 10 है, if I directly send, if I keep this tree like this, 1, 2, 4, 5, can I send 10 here? Can we do that? अगर maximum है तो definitely you'll go for node splitting. It's the but obvious answer, right? अगर maximum levels check करने, but maximum क्यों find करोगे? More are the number of levels, more will be the complexity. So in this case, is this allowed? 10, 13 and 14? It is not allowed because 10 cannot be on the right side of 12. This is not possible. तो अब लेफ्ट सिबलिंग से राइट सिबलिंग पे वैल्यू को जाना है तो डायरेक्टली तो जा नहीं सकती कि धक्का मारा और राइट साइड पे हो गई, राइट? सो दैट इज व्हाई 10 will take place here and 12 will come here. All right? Okay. So make sure in the question, बाकी questions आज होंगे, जो भी आपकी ये queries है, all these queries will be cleared when we will be talking about the previous year questions. अब तक जितने भी last 20 years में questions आए, I'll be discussing each and every single question, and there I'll tell you that from where you get the hint that which method you have to follow. मैम दोनों में डिफरेंस समझ में नहीं आया. डिफरेंस बेटा तब समझ में आएगा जब यहां पे भी ओके एवरी टाइम इफ यू आर गोइंग टू स्प्लिट, लेट मी कंप्लीट दिस ट्री. 4 and 4 is added. Next is 20. I want to insert 20. 20 will be added here, so let us add 20 here. Next 18. 18 will go where? It will be added here. Something like it comes out to be here we'll get 18 and then we had 20. So this is allowed. Now if 19 is coming up, 19 will come somewhere here, but that is a case of overflow. So now again 18 will go up. Yes. So here we'll get 4, 12, 18, 1 and 2, 5 and 10, 13 and 14. Here we have 19 and 20. This node is also inserted. 19 is inserted. Take the next node 17. 17 will be added where? 17 will go to the left, right of 12 and left of, because 17 is greater than 12, so go to right side, but 17 is smaller than 18, so left. So in this case you have to add this node. Next element. दोनों में difference अभी clear होगा. Let us add few more elements. Next is 16. 16 is coming up. So 16 will be added where? 16 is greater, less than 18, so 16 will be added here. कोई problem नहीं है. Next is 15. 15 needs to be added here. When you'll take 15, this comes out to be 13, 14, 15, 16, 17. That's a case of overflow, so 15 will go up. Right? So the tree will look like 4, 12, 15 and 18. And on the left we have 1 and 2. On the right we have 5 and 10. Here we will be having 13 and 14. On the right of 15 we have 16 and 17. And to the right of 18 we have 19 and 20. ओके जो हर्षा का डाउट है वो अभी सामने आने वाला है. 15 is added. Next 25. 25 will be added where? In this tree. कोई problem नहीं है. 23 will be added where? In this tree. No problem. Next want to add 24. 24 needs to join this node. Now in this case what will happen? It comes out to be 19, 20, 24. I want to add 24, 20, 24 and 25. This is a case of overflow, right? If it is not considering the concept of key redistribution, in this case what will happen? The splitting will be done on the basis of 13 or 23. When 23 is coming at this level, again this is a case of overflow. Understand this point very carefully. Here you'll get to know the importance of key redistribution. So 23, when 23 wants to join this, it's again a case of overflow. So 15 will go up. Yes? It will create one more level of the tree. 4 and 12 we have here, and here we have 18 and 23. On the left we have 12. On the right we have 5 and 10. In nodes में कोई change नहीं है. On the left we have 13 and 14. Here we have 16 and 17. Node was splitted on the basis of 23. So here we have 19 and 20. And on the right we have 24 and 25. Ma'am, that's not 12, it's 1, 2. Yeah, it's 1, 2. Somewhere I am not marking the commas. Alright? Now in this case, what happened? It is creating one more level. And we know that in a tree, more are the number of levels, more will be the complexity. Yes? अब यहाँ पे क्या हुआ? क्योंकि keys redistribute नहीं की. Problem किस में आ रही है? In this node. Problem is coming in this node. Its left sibling could have helped it. अगर यहाँ पे help मिली होती, 19 रूट पे चला जाता है, 18 यहाँ पे शिफ्ट हो जाता और 19 यहाँ पे आ जाता. In that case, do we need to go to the next level? Here, if you are not using the concept of key redistribution, it is creating the new level. Creating new level. So that is the difference between key redistribution and splitting. Node कब split होगी? When all the levels are completely full. Completely full है, sibling भी help नहीं कर पा रहे, key redistribute नहीं हो पा रही, then only in the worst case it will go to the next level. जब आपके पास leaf level पे space ही नहीं है तो definitely you have to go to the next level, right? So that is the difference between the key redistribution and without key redistribution. Now is this point clear? तो अगर आप keys को redistribute करते तो आपके पास next level पे it could not have gone to the next level. तो अगर आप key redistribution use कर रहे हो, so at every step you have to use the concept of key redistribution. It's not like कि जब next level create करने तब consider करने. For example, here when you had splitted the node first time, node split की तब तो आएगा ही आएगा, तब तो node split होगी. And after that, here you had splitted the node, but key redistribution के according, this could be the answer. Because here there was a case of overflow. So whenever there is a case of overflow, first of all check if its sibling is helping or not. If sibling is not helping, then go for node splitting. That is the concept of key redistribution. Is this point clear to everyone now? बच्चे ये ट्री देखने में ऐसा लग रहा है because I didn't had the sufficient space कि अलग अलग लेवल पे लीफ नोड्स. If you observe here, हमेशा आपके पास लीफ से फिर splitting हो रही है. So this means that in case of B tree or B plus tree, all the leaf nodes will be at the same level. Okay. So now we have inserted the element 24, 22 if you have to insert. if this is the tree, we are going for without node splitting. So next level is created. So I guess now you are comfortable that how to insert the nodes. 22 will be added here, 21 will be added here, and then 30 needs to be added. 30 will be added to the right, and 31 will be added here. This is without key redistribution. This is not exactly the key redistribution क्योंकि मैंने यहाँ पे कुछ steps पे we have not considered the concept of key redistribution. Okay, so whatever method you are following, throughout the question you have to follow that method. ऐसा नहीं है कि कहीं पे भी key redistribution use कर लिया और कहीं पे भी node split कर दी. Any doubt in the creation of B tree with even order, odd order, with the key redistribution or with the node splittings? Okay, now let's understand the concept of insertion is over. Now let's go for the deletion concept. Deleting the elements. Because in the index, you might be interested in inserting a new record या फिर existing record को delete करने. So this is why we need to perform the deletion. So let me give you some tree. Consider the following B tree. And let's assume that the order is 3. Order of the tree is 3. Or let's take a tree with more order. Let's say that order is 6. Order is given as 6. So this means that maximum keys allowed are 5. Minimum keys कितनी allowed होंगी? How many minimum keys are possible? Minimum keys possible are 3. Why is it 3? If maximum block pointers are 6, minimum block pointers will be 6 by 2, that is 3. If minimum block pointers are 3, then minimum keys will be 2. Yes or no? Yes, because of 50% occupancy, that is why we have considered the 50% occupancy. It depends on the order of the tree, right? आपने क्या किया? जो भी keys आ रही थी, you have just divided it by 2 and took its seal value. P by 2, if P is representing the order of the tree, then P by 2 gives you the minimum number of block pointers. And if minimum number of block pointers are P by 2, then the minimum number of keys will be P by 2 minus 1. This is what we have discussed in the first slide only. A and C E and F, and here it is pointing to H, K and L. This is pointing to a node which is having N and P. This is pointing to a node which is pointing to R and S, and this is pointing to a node which is having W, X, Y and Z. So this is the given tree, and in this tree I want to delete few elements. First of all, I want to delete H. So where is H? H is coming before M, later then G, so it's here. if I delete this record, is it ensuring minimum occupancy? Minimum number of keys are 2. So yes, 2 keys are there. So there is no problem. After inserting, you are checking for the maximum condition. After deleting every element, you have to check for the minimum condition. Now, delete next element. I want to delete T. If T will get deleted here, what will happen? This node is having a problem. This is a case of underflow. Because minimum keys should be 2, but now after deleting T, it comes out to be 1. So what will happen? First of all, it will ask, जब आप binary search tree में deletion करते हो, so the if a node is having 2 children, in that case, what's happening? The element is replaced by the in-order successor. If in-order successor is not there, then with the in-order predecessor. In-order successor or predecessor means it is taking the help from its children. Yes? So in this case, if you want to delete this node T, it will take the help from where? What will be its in-order successor? It's W. That is the leftmost or the smallest element of the right side, or you can replace it with the greatest element of or the last element of the left subtree. So this is going to take, W is going to replace this because this is the in-order successor of, of T. So now this has moved here. बिल्कुल आफ्टर डिलीटिंग एवरी एलिमेंट, फॉर एग्जाम्पल यहाँ पे T को डिलीट किया तो ये क्या चेक कर रहे हैं? 50% ऑक्यूपेंसी वाला रूल फॉलो हो रहा था? नहीं हो रहा था. सो दैट इज वाई इट हैज रिप्लेस दैट नोड विद सम एलिमेंट. नाउ नेक्स्ट आई वांट टू डिलीट सम नोड. लेट्स अज्यूम दैट आई वांट टू डिलीट R. In this case, what will happen? Delete R. If this is deleted, then it's a case of underflow. Because minimum number of keys that should be present is 2, but here only 1 key is present. Now what will happen? In order successor will be what? W. In order successor क्या आएगा बच्चे इसका? It will be W, right? So if I take here W, if I am going to take here W, then in that case what will happen? This is a case of underflow, so it will get the value from here. So it got X. Fine. यहाँ तक क्लियर हुआ? लेस देन 2 इज नॉट पॉसिबल. जहां पे लेस देन 2 होंगे वहां पे प्रॉब्लम आएगा. वाई नॉट प्रीडिसेसर? प्रीडिसेसर के केस में बच्चे यहां पे हेल्प कर रहे हैं. मिनिमम एवरी नोड शुड कंटेन 2 कीज. अगर इसने एक की यहां पे सेंड कर दी तो यहां पे अंडरफ्लो की प्रॉब्लम आ जाएगी. हेल्प कब करोगे? फॉर एग्जाम्पल यू आर गोइंग टू राइट अ पेपर एंड इन द पेपर यू नीड 2 pens, one black and one blue. And somebody is asking that, can you borrow 1 pen? कब borrow करोगे? कब दोगे किसी को पेन? जब आपके पास कुछ एक्स्ट्रा पेन होगा. 2 are mandatory for you. तो यहाँ पे कुछ एक्स्ट्रा एलिमेंट ही नहीं है. How can it help? Hi, good morning, Anju. Who asked this doubt? Lalit. After exam completion, during the exam, right? Minimum condition is every node needs to have 2 keys. This is already having 2 keys. तो ये एक की कैसे दे सकता है? It's not possible, right? Thank you so much. All right. Now let's delete one more element. I want to delete a node E. I want to delete this node. In this case, what will happen? If I'll be deleting this node, it will be asking the help. जब भी आप कुछ गड़बड़ करते हो, आप किससे हेल्प मांगते हो? You ask your sibling, please बचा लेना यार, right? और अगर sibling ने बोल दिया कि नहीं, I can't help you out, then what happens? Then you have to go to your parents and tell them this is the blunder that you have did, right? Bro is not working. Bro is not helping you. कुछ बहुत बड़ा पंगा कर दिया. Bro is also scared, right? So in this case, I want to delete this node E. So this is a case of underflow because every node needs to have two keys. God तो directly आके help नहीं करने वाले, तो directly आपको जाके क्या करना पड़ेगा? You have to tell your parents. So in this case, this node is suffering from the problem of underflow, so it will ask its sibling, can you help me out? He is not helping. Can you help me out? No, I don't have the extra key, I can't help you out. Now in this case, what will happen? So go to the parent. Parent क्या बोलेगा? ठीक है, I'll help you out. So in that case, when both the siblings are not helping, if you take this D down here, then in that case, this node will be having a problem of underflow. So if this is the problem, if siblings are not helping, in that case, we have to combine the nodes. So in this case, go for node combine. If it's a case of overflow, then you were going for node splitting. Now, if it's a case of underflow, go for node combine. So finally, in the tree, you will be getting M. This is combined with both of its children. So on the left of M, there is only one node. So in this case, D will be joined. So if D is joined, so G will be having a problem, because if D is joined, combined with its children, A, C, D and F you got here, and this comes out to be KL. Baki pura tree as it is here, it is pointing to Q. And then on the left, here we had X also. This is pointing to N and P. This is having S and W. This is having, X is already shifted. So here we are having Y and Z. Now, is this the correct tree? This is not a correct tree. Now, there is a problem of underflow here. There is a problem of underflow at this node. So it will ask the help from its sibling. Sibling is not helping. So go for node combine. So this means that when you have deleted the element E, in that case, two nodes will be combined. So after deleting E, the tree will look like this is G, M, Q and X. On the left of G, there is a node which is having the elements A, C, D and F. On the right of G, it's K and L. On the right of M and left of Q, that is N and P. On the right of Q, it's S and W. And on the right of X, it's Y and Z. So this is the resultant tree. Maximum keys कितनी हो सकती है? 5. So none of the node is containing more than 5 keys. So now this is the correct tree. Okay. So this is how deletion can be performed. So after deleting every element, you have to check for the minimum condition. Just let me know if it's clear to everyone. Clear? Okay, so if let us delete one more element. Now I want to delete the element S. Delete S. This is the final tree. In this tree, I want to delete the element S. If S is deleted, this is a case of underflow. This is a case of underflow. Now it will ask the help from its sibling. Siblings are not helping. Then go to parent. Who is the parent of this one? You can merge this node with Q or with X. It's completely okay. Let's assume that this is merged with X. So the resultant tree will be G, M and Q. And on the left of G, whatever is there, there is no change. So it's A, C, D and F. And on the right of G, we have K and L. On the right of M, it's N and P. And on the right of Q, so this comes out to be W, X, Y, Z. It's W, X, Y, and Z. Because S is already deleted, so that's why we are going for node combine. Comfortable? So conclusion is whenever some node is some element is deleted from a node, and that node is going for underflow. So this means that node is not satisfying the minimum criteria. Then in that case, first of all, it will ask the help from siblings. If siblings are not helping, they are also having the minimum number of elements, then in that case, it cannot help. Then go for node combine. That is the only concept of deletion. और अगर parent node delete हो रही है, then it will check for in order predecessor or successor. It will ask the help from its children. And if its children are not helping, siblings are also not helping, then go for node combine. Clear? So this is the deletion in B tree. Just let me know if it's clear to everyone. Okay. Now, sometimes what happens is they'll give you the order and they'll say that with the order P, what will be the maximum number of block pointers or the minimum number of block pointers, minimum number of keys or maximum number of keys. So let's derive few more formulas. For example, order is given as P. That is nothing but the maximum number of block pointers. It's the maximum number of block pointers in B tree node. Shweta will take more examples. Let's finish the concepts first. And more number of questions will be taken in today's special class. जितने भी type के questions आ सकते हैं B tree और B plus tree में, we will be having the practice in the special class. So maximum number of block pointers in a order is nothing but it's the maximum number of block pointers in a B tree node. बिल्कुल B plus tree आज ही complete होगा. B tree पे थोड़ा सा इसलिए time लगता है क्योंकि बिल्कुल node का idea ही नहीं होता है. B plus tree में एक छोटा सा difference I'll just let you know and rest everything is same. Okay. So height. First of all, let's focus on the minimum number of nodes. Minimum number of block pointers and minimum number of keys. ब्लॉक पॉइंटर से एक काम हो गए ना मैम, मतलब चटर्जी मुझे आपका क्वेश्चन समझ में नहीं आया. ओके, सो व्हाट इज द हाइट ऑफ द रूट नोड? Height of a root node is 0. And if I talk about the level of a root node, that is 1. अगर आपको height पे आता है या level पे question आता है, then you can refer to that. First of all, we are considering height 0 means I'm talking about the root node. For root node, height is 0 and level is 1. Block pointer से एक कम होंगे क्या ना? Okay, let's not talk about b plus tree right now. Otherwise, you will get confused. Let's go step by step. Beta, topic khatam hone ke baad, when I'm asking, is there any doubt, then ask your queries. Agar beech mein hi you will keep on asking the question, then I won't be able to cover the topic in a flow. तो flow break होगा तो आपको जिस तरीके से revision करनी है आपको उसमें problem आएगी. Yes, key is always block pointer minus 1. This point we have discussed so many times. So if order is P, तो maximum number of keys कितनी होंगी? That is P minus 1. We know that. And minimum number of keys will be how much? Because here we are focusing on the minimum number of keys. What will be the minimum number of keys? Minimum number of block pointers will be P by 2. And key will be 1 less than the block pointers. So for root node, what are the minimum number of nodes? Root node है तो definitely एक ही node होगी. Root level पे height 0 पे there will be only one node and that is the root node. How many minimum number of block pointers are possible? Maximum is P, but there is an exception for root level. Minimum pointers कितने हो सकते हैं? It can be 2. And minimum block pointers अगर 2 हैं तो minimum keys कितनी होंगी root node में? It will be 1. Correct? Now, go to the next height. Height 1. Height 1 पे if the previous node is having 2 block pointers, अगर 2 block pointers है तो next level पे nodes कितनी होंगी? That is equal to the previous number of block pointers. So block pointers are 2. So here the minimum number of nodes will be how much? 2. Minimum number of block pointers. Except for root node, minimum constraint should be satisfied. Minimum number of block pointers will be how much? To ensure 50% occupancy, one node will be having minimum of P by 2 block pointers. Yes or no? यहाँ पे बेटा मैंने order P लिए, it's not 2 or 3. So it will be one node will have P by 2 block pointers, but at the next height, 2 nodes are there, so the block pointers will be 2 into P by 2. And what will be the minimum number of keys? In one node, minimum number of keys are P by 2 minus 1. At this level, how many nodes are there? It's 2 nodes, so 2 into P by 2 minus 1. Go to the next height, height 2. अब height 2 पे क्या होगा? How many nodes will be there? जितने previous level पे आपके पास block pointers है, क्योंकि block pointers ही तो next level पे जाके nodes बनती हैं, right? So in the previous level, how many minimum number of block pointers are there? 2 into P by 2. So it will be having 2 into P by 2 nodes. Are you following this concept? I'm giving you the generalized concept. If they are giving the value of order of P 3 or 4, then easily you can get the values, right? यहाँ तक clear है? Now, if these are the number of nodes, we have to find out what will be the minimum number of block pointers. In one node, minimum number of block pointers in one node is equal to P by 2. And how many nodes are there? It's 2 into p by 2. So into these many nodes are there, and in each node block pointers are p by 2. So can I say that this is nothing but 2p by 2 whole square? Simple. So these many block pointers are there with height 2. What will be the minimum number of keys? In one node, minimum number of keys are p by 2 minus 1. And how many nodes are there? It's in one node, minimum number of keys are p by 2 minus 1. But number of nodes are, at this height, number of nodes are 2 into p by 2. Similarly, go to the next height 3. So what will happen here? It will be having the number of nodes जितने आपके पास previous level में block pointers थे. It's 2p by 2 square. How many block pointers will be there? These many nodes are there, and in each node p by 2 block pointers are there. So this comes out to be 2p by 2 whole cube. And these many nodes are there. In one node, 2 by p by 2 square nodes are there. And in each node, the number of keys are p by 2 minus 1. यहाँ तक clear है? Have you observed this pattern? Yes or no? Okay. So have you observed some pattern? If the height is 1, then it's p by 2 raised to power 0. If height is 2, then it is p by 2 raised to power 1. If height is 3, then p by 2 by raised to power 2. If the height is h, then this will be what? 3 है तो power is 2, 2 है तो power is 1, 1 है तो power is 0. So this comes out to be p by 2 raised to power h minus 1. If height is 3, then power is 3. If height is h, power will be h. And this comes out to be 2 p by 2 raised to power h minus 1 p by 2 minus 1. If you have to find out with the levels, then you can consider the levels. For example, level, if the height is 1, level will be 2. Level will be 3. Level will be 4. Level will be h plus 1. So if they are asking for the formula for minimum number of nodes, can you calculate that? If I want to find out the minimum number of nodes with order p, what do you have to do? You need to take the sum of all of these. Yes? First of all, let me know if this is clear, because after that I have to just take the sum, and Lalit has identified it right. This is going to form a GP series. And you know the formula for sum of GP series as well. So I want you to return the formula with the minimum number of keys and the minimum number of nodes with height h. Minimum number of nodes with height h will be equal to, what will be the minimum number of nodes? So it's the sum of all the nodes at height 0, height 1, height 2, height 3, and so on up to height h. This comes out to be 1 plus, here you can take this as p by 2 raised to power 0. So 2 is common. We are left with p by 2 raised to power 0 plus p by 2 raised to power 1 plus p by 2 raised to power 2 and so on up to p by 2 raised to power h minus 1. This is nothing but this is a GP series. This is a GP series with common ratio p by 2. First term is 1. Number of terms in the series is 0 to h minus 1. This means that total number of terms are h. What is the sum formula? With n terms, it's depends on the common ratio is greater. So here the common ratio is greater than 1. So it comes out to be r raised to power n, where n are the number of terms, minus 1 divided by r minus 1. So just substitute this value here for this equation. So the minimum number of nodes comes out to be 1 plus 2. First term is 1. So it's 1 only. Common ratio is p by 2. Number of terms are h minus 1 divided by r minus 1. 2h minus p by 2 minus 1. Is this clear? So similarly, quickly return the formula for minimum number of keys in binary tree, in B tree with height h. Minimum number of nodes we have calculated. Minimum number of keys in B tree with height h and order B. Minimum number of keys we have already calculated. Just take the sum of that. So it's 1 plus 2 p by 2 minus 1 plus 2 into p by 2 p by 2 minus 1 plus 2 p by 2 square p by 2 minus 1 and so on with the height h. Again that comes out to be a GP series, and just solve that GP series. So here we have 2 p by 2 h minus 1 p by 2 minus 1 and that's it. So in this GP series you can take 2 p by 2 minus 1 common, 1 plus 2 p by 2 minus 1. This is the common term in all the terms, and here we have p by 2 raised to power 0 plus p by 2 raised to power 1. Just simplify this GP series. P by 2 raised to power 2 and so on. P by 2 raised to power h minus 1. Again, this is a GP series. Identify the terms. GP series with the first term p by 2, that is nothing but 1. Common ratio is p by 2. Number of terms are h, 0 to h minus 1, so number of terms are h. So just substitute the values. Ma'am, in B plus tree, if we have overflow at leaf node, then do we, you are asking a question related to B plus tree. Just for that, you need to wait for 5 more minutes. I have not discussed the concept of B plus tree yet. Okay, so just give me 5 more minutes. I'll discuss that also. So just apply the formula. So this comes out to be 1 plus 2. This term is as it is, p by 2 minus 1. First term is 1. Common ratio is p by 2. Number of terms are h minus 1 divided by p by 2 common ratio minus 1. And this will be cancelled out with this one. So this comes out to be 1 plus 2 p by 2 h minus 1. This is the formula for minimum number of keys with height h. If you have to find out the minimum number of keys with level L, same thing, minimum number of keys सिर्फ level है, number of keys with level L. What is this level? It's height plus 1. Whatever is the height, plus 1 is the level. If height is 1, level is 2. If height is 2, level is 3. So it is h plus 1 gives you the level. So in simple terms, we can say that this means that this is nothing but h is nothing but level minus 1, or you can say that. So already you have got the formula for h, so just replace it with L. So this comes out to be 1 plus 2 p by 2. Now you have to calculate in terms of L minus 1. So this is the formula. Clear? This is with minimum number of nodes, minimum number of block pointers, and the minimum number of keys. Similarly, we can determine the formula for maximum number of nodes, maximum. Ma'am, how will you solve PYQs? How will you solve means? Beta discussion के साथ जैसे करते हैं. So all the PYQs will be discussed in today's special class. I have discussed this point so many times that whatever topic we are going to cover on the YouTube, same day we will be discussing its previous year questions in the special class, which is free of cost. Anybody can access those sessions. Just you have to register yourself and you have to apply the referral code. That is it. Right? So maximum number of nodes, height, with height h we have to calculate. Maximum number of nodes, the way we have calculated for minimum number of nodes, similarly we have to identify for maximum number of nodes, maximum number of block pointers, and maximum number of keys. Ma'am, he is saying, will you solve? Yes, definitely. बेटा वो आपको मालूम है डेली जो भी टॉपिक खत्म होता है स्पेशल क्लास में खत्म होता है. PYQ सारे स्पेशल क्लास में डिस्कस हो रहे हैं. So if the order is P, then the maximum number of block pointers will be P, and the maximum number of keys will be P minus 1. I'm sorry, quickly I read the comment and वो you or will change हो गया. And accordingly I gave the answer. I'm so sorry for that. So, Rockstar, if you want to attend the previous year questions, so you can join today's special class at 9 p.m. and my profile link is given in the description box. So, every question will be discussed in detail. So, quickly find out this one. I guess now you are comfortable with this concept. फटाफट से find करो. Root means height 0. If they are asking for the maximum number of nodes, root level पे कितनी nodes हो सकती हैं? Maximum 1 node, that is the root node. Maximum number of block pointers कितने होंगे? Whatever is the maximum capacity. Maximum number of keys will be p minus 1. At height 1, maximum number of nodes will be, it depends on the number of block pointers of previous level. अगर p block pointers है तो next level पे nodes कितनी होंगी? p. Maximum number of block pointers will be, in one node the maximum number of block pointers are p. And number of nodes are p, so total number of block pointers at height 1 will be p square. P nodes are there. In one node, maximum number of keys are p minus 1. Similarly, at the next level, how many nodes will be there? Equal to the number of block pointers at the previous level. Maximum number of block pointers कितने होंगे next level पे? Number of nodes are p square. And each node can have p block pointers, so it will be p cube. Number of nodes are p square. Each node can have maximum p minus 1 keys. Three. Rockstar is saying that he had given the GATE exam previously and got the rank 2893. This time he's very nervous, so don't get nervous. Already if you have prepared the syllabus, this means that you need to solve more practice questions. You need to revise the previous year questions, quick revision, and just focus on the mock test or the quizzes. This will boost your confidence level. Okay, so with 3 it will be p cube, p raised to power 4, p cube into p minus 1. So I hope that you have observed the pattern. With the height h, if it's the height 3, then it is p raised to power 3. If it is height h, then it will be h. If it is height 3, then it is p raised to power 4. So if it is height h, then it will be p raised to power h plus 1. If height h, then it will be p raised to power h into p minus 1. Now, if they are asking for the maximum number of nodes, take the sum of this one. This is a GP series. Take the sum of this one. If they are asking for the maximum number of block pointers or maximum number of keys, so ultimately this will form a GP series. Quickly return the formula for maximum number of keys. Remaining you can find out. Maximum number of keys. This will be p minus 1 plus p into p minus 1 plus p into p square into p minus 1 and so on, p raised to power h into p minus 1. So if you observe here, p minus 1 is common term. You can take it as common. So it's p raised to power 0 plus p raised to power 1 plus p raised to power 2 and so on. This is going till p raised to power h. GP series p minus 1. First term is 1. Common ratio is p. Number of terms are h plus 1 minus 1 divided by p minus 1. This will get cancelled out. So this comes out to be p raised to power h plus 1 minus 1. And if they are asking for minimum number of keys with level L, so with level L, this will be maximum number of keys. Maximum number of keys with level L. Level is 1 less than the height, so it comes out to be p raised to power L minus 1. Similarly, can you find out the maximum number of nodes? Just it's the GP series. Right? Other type of question, if they are asking for what will be the number of minimum or the maximum number of pointers which will point to null in the B tree. Maximum number of pointers that will point to null in B tree. कितने pointers null को point करेंगे? Block pointers कौन से null होंगे? Block pointers of the leaf nodes. All the block pointers of the leaf nodes will point to null. Leaf nodes means at the height edge. So if they are asking for the maximum number of block pointers which are pointing to null, that is p raised to power h plus 1. So this is the maximum number of block pointers pointing to null. क्योंकि हमें मालूम है अगर लीफ नोड है तो उसमें नो चाइल्ड इज देयर, सो ऑल द ब्लॉक पॉइंटर्स विल बी पॉइंटिंग टू नल. Similarly, if they are asking for the minimum number of block pointers which will point to null, what will be that? Minimum number of block pointers which are pointing to null. Minimum number of block pointers pointing to null. Okay. So this is all about B trees, insertion, deletion, finding the maximum number of pointers, minimum number of pointers with height h, with the or with the level L and something like that. What if you are given with the number of keys and you have to find out the height? It's the reverse way. कोई प्रॉब्लम नहीं है. So if you are given with the minimum number of keys and you have to find out minimum number of keys means they are asking for the maximum height, and if they are asking for the minimum height, then you have to use the formula of minimum number of keys. So minimum number of keys with height h is nothing but that is 1 plus 2 p by 2 raised to power h minus 1. Now from this, can you calculate the height? This is the formula to have minimum number of keys with height h. अब इसमें से बेटा मुझे height find करनी है. So how will you calculate that? Simplify this expression only. So minus will come here. So this comes out to be p by 2h is equal to n minus 1. Then this was multiplied, so it will be divided. Now this was minus, this will be plus. I want this value, so this means that take log on both sides. Take log on both sides. What will be the base? It will be p by 2. So this comes out to be h is equal to log. I'm just giving you the idea how you can derive one formulas from one basic formula. So it's n minus 1 divided by 2 plus 1. This is nothing but the at most or the maximum height. If they are asking for minimum height, then you have to calculate. You have to use the formula using the maximum number of keys. So maximum number of keys are nothing but n is equal to p raised to power h plus 1 minus 1. From this you have to calculate the value of h. So this comes out to be p raised to power h plus 1 is equal to n plus 1. Take log on both sides. Log base p. So this comes out to be h plus 1 is equal to log p n plus 1, and h comes out to be log p n plus 1 minus 1. if you have to find out the height from the given number of nodes. Clear? On the basis of insertion, deletion, or the number of nodes or heights, you can get one question. Other question can be on the basis of the block pointer. Let's discuss one question. Let's assume that P represents the maximum number of tree pointers in a B tree node, and key is given as, key is 10 bytes long, block size is 512 bytes, data pointer is given as 8 bytes, and block pointer is given as 5 bytes. Then what is the maximum value of P? What is the maximum value of P? This is one of the very important type of question that can be asked in the exam. So what is the formula? Ma'am, हमें formula ही नहीं याद. Do you know the structure of a B tree node? Internal node? If the order is P, then P block pointers are available. If P is the order, then the number of keys will be P minus 1. And with every key, there is a record pointer. And this should fit in the block. It should less than equal to block size. This is the formula. Now substitute the values in this. Substitute the values. What is P? P is what you have to calculate. Block pointer is given as 5 bytes. So this comes out to be 5P plus P minus 1. Key is given as 10 bytes. P minus 1. Record pointer is given as, record pointer is nothing but that is the data pointer. It's 8 bytes. It should be less than equal to 512. Just simplify this. This comes out to be 5P plus 10P plus 8P minus 8 less than equal to 512. Just simplify this. 5, 15 and 23 P minus 18. So this side it comes out to be plus. So this comes out to be less than 530. So P will be less than equal to 530 divided by 23. What will be the value? This comes out to be 23 point something. So which value you have to take? Floor or seal? If it's in the points, we are saying that whatever is the value here, if you are getting 23.5, P will either be less or equal. So this means that if less value you have to take, you need to take the floor value. So that will give you 23 answer. बहुत सारे क्वेश्चंस बेटा इस टाइप पे रिपीट हुए फ्रॉम बी ट्री और बी प्लस ट्री. सो दिस इज ऑल अबाउट B trees and the different concept, different formulas that can be asked, can be formed on the basis of B tree. If you have any doubt, you can ask. Otherwise, we'll move on to the concept of B plus tree. Any doubt? Hurry up. Okay, so it's clear. Next we have B plus tree. Already we know the difference between B tree and B plus tree. In B plus tree, the sequential access and the random access is allowed. How it is allowed? Okay, so basic terms are same. For example, if order of P is given to you, so this means that this represents the maximum number of pointers in a tree, The difference is here every node is present at, in B plus tree, the main advantage is every record, every key is present at the leaf level. In case of B tree, it was not able, it wasn't available at, all the keys were not available at the leaf level. So that is why sequential access was not supported by B trees. Ma'am, can you please write the important formula on one slide for B tree? बेटा आप खुद लिख लो, इतना काम तो कर लो आप. Otherwise, at the end, let's cover the concept of B plus tree first. When you'll be making your short notes, so definitely in that you'll get that. Okay. So there is this difference in the structure of, since all the keys will be present at the leaf level, this means that at the internal level, we need not to have the record pointer, because record pointer tells you that where that record is present in the database. So in the internal node, if the order of tree is P, if the order of a tree is P, then it can have P block pointers, block pointer 1, block pointer 2, block pointer 3, and so on up to block pointer P. So how many keys are possible? It's just like the previous case. P minus 1 keys will be present. P minus 1. The only difference is, in this case, there will not be any record pointer along with the keys, because all the record pointers, since all the keys are maintained at the leaf level, so all the record pointers will be available in the leaf node only. Rest everything is same. If here the value is X, in this case we are having the value something like X. So X, earlier we were saying that it should be less than, it should be X, the value key should be greater than K1 or less than K2. Here it was X, K2 less than, and K3 and so on. So here the keys were X should be less than, this was, sorry, Kp minus 1, and there is no constraint on the up value. Correct? But there is a small difference here. Whenever you are going for node splitting, so first of all, that key should be maintained at the leaf level. तो इसका मतलब ये है कि अगर key यहाँ पे 1 up level पे गई है, then this value should be maintained at the leaf level. So if K1 is at the root, so its value should be maintained at the leaf level. X is greater than K1. Okay. And if other cases, now where this value we need to maintain, in the left side or in the right side, both are valid. If you are maintaining here in the left, then in the whole tree you have to maintain its value in the left child, and if you are maintaining the value in the right child, then it needs to be maintained in the right child. It needs to be maintained at the right child. Either follow this method or follow this method. Both are not possible. Clear? Either A or B, but not both. Either follow A or B, but combination of both is not. Combination of both is incorrect. So the main purpose of maintaining the value at the leaf level is to support the sequential access. We will be having copy of root node in our child. Yes, whenever the node splitting is going to take place, its copy will be maintained at the leaf level in order to support the sequential access. That is one difference. And this is the structure of the internal node. So in internal node, if I write here, what will be the formula? For this internal node, P block pointers are there. If the order of a tree is P minus 1 keys are there. That is it. And this should fit in one block. No record pointers are there at the leaf level. Clear? Now, next we have the structure of the leaf node. Leaf node. In the previous case, there was no block pointer, but here one node will be pointing to the next node. So one block pointer is there. And with every key, obviously the remaining block pointers will be null. If it's key 1, key 2, key 3, obviously it needs to be represented, it needs to point to the record in the database, so it will be having the record pointers. All the record pointers are available at the leaf level. So it's a record pointer P minus 1. So what is the structure, or what will be the formula for the leaf node? Are you following this concept? थोड़ा सा इसको हम quickly कर रहे हैं because already we have discussed this in B tree. So here this is having one block pointer, P minus 1 keys, and P minus 1 record pointers. This is for leaf node. Rest everything is same, that the elements in the key should be in the ascending order, and next is every internal node except the root node should ensure 50% occupancy, etc., etc. So this is the only difference between B tree and B plus tree. Is this clear? So if it's clear, then let's move on to the construction of B plus tree. Construction of B plus tree. Let's assume that we want to construct a B plus tree. Construct a B plus tree. See, majority times they'll be asking the questions on the basis of finding the value of the order P. So in that case, you need to remember, you need to consider the formulas. So formulas are very, very easy. Just you need to consider the structure of a node. Okay, and on the basis of that, you can easily write the formula. So you need not to cram the formulas. Ma'am, कितने आज का session है? Last 20 more minutes to go. जो फोकस होता है वो टाइम पे होता है कि कितना टाइम हो गया सेशन के लिए और कितना और टाइम चाहिए. बेटा अगर क्विक रिवीजन चाहिए तो मैं ये टॉपिक 1 आवर में फिनिश कर सकती हूँ, बट इन दैट केस जो भी आपकी इतनी क्वेरीज आ रही हैं दोस वॉन्ट बी हैंडल्ड. सो B plus tree with order 4 we want to construct, and the set of keys are given as 5, 10, 15, 8, 20, 3, 1 and 0. Order is 4. If you are inserting the elements, this means that we have to consider the maximum constraint. Maximum number of block pointers are 4. So maximum number of keys will be equal to, it will be equal to 3. So construct the tree. First of all, you are getting 5, 10 and 15. First of all, you are going to insert 5. 5 is inserted here. कोई problem नहीं है. 10 is also possible. No problem. 15 is also possible. No problem. Next, 8 is coming up. So if 8 is coming up, it will be coming here, and this is a case of overflow. Till this point, everything is same. यहाँ तक कोई problem नहीं है. If the order is even, then you have to use the concept of left biasing or right biasing. Node will split on the basis of which element? 8 or 10. Anything is possible, depends on whether you are going for left biasing or right biasing. Okay, let's assume that we are working on right biasing. I'm using right biasing. So in B3, what you were doing, 8 is present at the root level, and here this is pointing to 5, and this is going to point to, this will point to 10 and 15. This is what we were doing in B3. यहाँ तक सेम है. अब यहाँ पे डिफरेंस क्या आएगा? When first time node splitting is taking place, this record should be maintained at the leaf level, right? Already in this case, I am taking 2 elements here. So let me keep the copy on the left side. Let me keep the copy on the left side. So this is the basic change. So copy is maintained of the node which is going from leaf level to the internal level. Clear? This is the difference. Next element is 20. 20 is greater than 8, so 20 will be added to the right side. This is allowed. It's not a case of overflow. Next element I want to insert is 3. 3 will be inserted where? 3 is smaller than 8, so it will be inserted to the left of 8 in the ascending order. Next element that I want to insert is 1. So 1 is smaller, so 1 will be added here. It's a case of overflow. Now what will happen? Node splitting will take place. So overflow. Now node splitting will take place. So 3 will go where? To the internal level. So 3 is moving from leaf level to the internal level. So here we have 3. We have 8 here. On the left of 3, we have 1. And where we are maintaining the copy? We are maintaining the copy in the left child. So 1 and its copy will be maintained here. 3. On the right of 3, we have 5 and 8. 5 and 8. On the right of 8, we have 10 and 10, 15 and 20. Now, next, what will happen? I want to insert 0. So 0 will be inserted here. No problem. So if you observe here, all the elements which were given to you, 5, 10, 15, 8, 5, 10, 5, 10, 15, 8, 23, 1, 0, 23, 1, 0, all the elements are available at the leaf level. So this is how we have to insert the elements in the tree, in the B plus tree. This is the only difference. Is this clear? Anybody having any doubt? Let us insert some more elements. Let's assume that I want to insert the elements 21, 22, more. So if I'll be inserting here 21, what will happen? This is a case of overflow, so node will split. 15 will go up. So here we'll get 3, 8 and 15. This is pointing to there is no change. It's 0, 1 and 3. Here we have 5 and 8. Copy will be maintained in the left child, 10 and 15. And here we have 20 and 21. 20 and 21. Next, I want to insert the element 22, 23. 22 will be inserted here, no problem. Next, I want to insert the element 23. So it's a case of overflow. So which node will go up? 21 will go up. In this case, what will happen? When 21 is coming here, again it's a case of overflow, so 8 will go up. So at the root, we are getting 8, 3, we have 15 here, 15 and 21. In its left child, we have the elements 0, 1, 3, and in the right child, the elements are 5 and 8. Elements are 10 and 15. Elements are 20 and 21 because 21 is going from leaf level to the internal level. So its copy will be maintained. And here we have the elements 22 and 23. Now, have you observed one point? When first time splitting is taking place, 21, leaf level set is going to the internal level, then we are maintaining the copy. Here, 8 is moving to the next level, but here I haven't maintained the copy. Why is it so? Ma'am, partiality क्यों कर रहे हो? Why the copy of 8 is not maintained here? Copy is not maintained here because already it's maintained at the leaf level. Right? बच्चे जब first time आपने root create की थी, first time splitting हुई थी, so this for 8 you maintain the copy. But now root के लिए ऐसा नहीं है कि root है तो इसलिए copy maintain नहीं होगी. For each and every element should be present at the leaf level. So whenever first time splitting is taking place, or in other words, you can say that whenever an element is moving from the leaf level to the internal level, that point of time you have to maintain the copy. Because we need to have all the elements present at the leaf level. But when it is moving from internal level to internal level, it doesn't matter because already its copy is maintained at the leaf level. Right? So this is how the node splitting is taking place in case of B plus tree. If you observe here, for every element there is a record pointer which will be pointing to the record, if this is the database file. If this is the database file, so it is pointing the record in the database file, where it is available in the database file. So corresponding to every key, there is a record pointer in the leaf level. But यहाँ पे it's not pointing to the database. It's not referring to the database. And in order to have the sequential access, there will be one block pointer which will be pointing to the next node. One block pointer which will be pointing to the next node. One block pointer pointing to the next node, pointing to the next node, and this is null. If you observe here, everything is in the sorted order. And if you want to access all the keys in the sorted order in a sequence, so it is maintained at the leaf level. So that is why we have said that B plus tree also supports the sequential access. Is this point clear? So this is the only difference between the B plus tree construction. Let's solve some questions. जितना डिटेल में हमने किया इतना डिटेल में है नहीं है सिलेबस में, but still we have discussed everything in so much detail. I just hope that it's clear to everyone. Let's assume that the size of key is given as key is 9 bytes long. Let's assume that key is 9 bytes long and the block size is 512 bytes. A record pointer is of 7 bytes. Block pointer is of 6 bytes. What is the maximum possible order? What is the maximum possible order of B plus tree and node is given as the leaf node? So what will be that? What will be that? Hurry up. Anybody got the answer? What is the structure of the non-leaf node of the B plus tree? It does not contain any record pointers. So if order is P, so it will be having P block pointers and P minus 1 keys only. And this should be less than equal to the block size. If it is less than equal to block size, now you are given with the values. So P is the order that you have to find out. Block pointer size is given as 6 bytes plus P minus 1. Key is 9 bytes long and it is less than equal to 512. So this is 6P plus 9P minus 9 less than equal to 512. So this comes out to be 15P less than equal to 521. P is less than equal to 521 divided by 15, and you know that which value you have to take. Since it is less than, so we have to take the lesser value. For this we will be using the floor function, and this comes out to be approximately 34. Alright. So finally the conclusion is, if they are asking for the minimum number of node splittings, then you have to consider the concept of key distribution. What are the advantages of key redistribution? What are the advantages of key redistribution? First thing is, वेरी गुड धर्मेंद्र, गॉट इट राइट. या बाकियों ने 34. श्वेता इज रिटर्निंग 34.7. बच्चे अगर आपको ऑर्डर बताना है तो पॉइंट्स में हो सकता है ऑर्डर. ऑर्डर कैन नेवर बी इन पॉइंट्स. What are the advantages of key redistribution? First of all, levels will not increase. Second thing is space is used efficiently. Space is utilized efficiently. So these are the major advantages of key redistribution. कब use करना है? When they are asking for minimum number of minimum number of node splittings or minimum number of levels, जहाँ पे भी minimum term आ जाए. Or if nothing is said, then also go for key redistribution. Ma'am, why? Because it is having some advantages over the other concept. Okay? Any doubt? If no doubt is there, so let me discuss the schedule. Today we will be having one session at 7 p.m. in which I'll be taking important questions from C programming. Important types of questions from C programming. This is the schedule for today's classes. And tomorrow, guys, will not be having any session. Tomorrow, no class will be there. Okay? So many formulas you explained. अगर बच्चे आप इसको quickly revise करोगे ना, you'll understand कि कोई भी formula हमने discuss ही नहीं किया. It's all based on the concept. Just consider the structure, understand the difference between the B tree and the B plus tree. If the structures of the nodes is clear in your mind, then easily you can derive all these formulas on your own. मैंने कोई भी formula आपको directly दिया कि this is the formula और इसमें values आएंगी तो substitute the values? No. And in today's special class, this will be on YouTube. And in today's special class, we will be covering previous year questions on file organization. File organization basically means what all topics we have covered under this. We have covered the concept of indexing, multi-level indexing. So जो भी कल और आज के सेशन में हमने टॉपिक्स खत्म किए, I'll be taking the questions from all these topics. Multi-level indexing, that was static, and then the questions asked on the basis of B tree or B plus tree. So I'll be taking the PYQs on these topics in today's special class, and the timing for today's special class is same, that is 9 p.m. And this will be the YouTube session for today only. And this is the note for you guys. Tomorrow I'll not be taking any session. So please make a note of this thing. मैम आपने ग्राफ का PYQs करवाए हैं, all I have seen in YouTube, but less no questions are solved. See, the solutions for each and every question is available under the Plus subscription. Chatterjee, if you have the Plus subscription, then you can refer to the solutions of previous year questions under that video. Okay? तो बेटा सारे क्वेश्चंस डिस्कस हुए हैं, डिटेल में हुए हैं, बट ऑल दोस आर अवेलेबल अंडर द प्लस सब्सक्रिप्शन. Any other query? Mool mantra for success is just the practice. Today it is the age of competition and all the competitive exams are based on speed, accuracy and logic which requires constant practice. तो बेटा practice करते जाओ, चाहे आपने पहले exam दिया है, नहीं दिया है, or this is the first attempt, do the practice and special classes are free. Let me also write here as well because बहुत सारे students को confusion होती है कि special classes, paid classes and these are free classes. But for this you have to apply the referral code and referral code is given, referral code is mentioned on the screen. Date लिख दो ना मैम schedule में, कौन सी date? Okay, this is the schedule for 26th of January and tomorrow means on 27th we won't be having any session. Okay. So this is all about this session. I'll see you at 7 p.m. and if you are following the sessions for the first time and you have not joined our Telegram group, to get the notifications, to get the links of the live sessions, you can join our Telegram group, that is Let's Crack Gate CSE. And definitely if you like this video, click on the like button, and if you have not subscribed the channel, click on the subscribe button, hit the bell icon for the notifications of new videos. And if you have any doubt, any query, you can write in the comment section, or if you have any suggestion or any feedback, then you can fill out the feedback form. Okay, and link of feedback form is given in the description box. To follow my sessions on the special or the plus, my Unacademy profile link is given in the description box. To unlock the free plan, चाहे आपको free classes access करनी है or you want to get the paid subscription, use the referral code to get 10% discount. Free classes है बच्चे, उसमें तो क्या ही discount मिलेगा. तो free के लिए just you have to unlock the free plan, and if you are planning to get the subscription, then use this code to get 10% discount. And what all subjects are covered on the YouTube. Algorithms is available. PYQs हम start करेंगे after 2 days of algorithms. Data structures and programming, its PYQs are also discussed. Operating systems along with PYQs is over. Digital, its PYQs are available in the special. Programming के PYQs on programming, PYQs on digital, PYQs, these special classes are free. PYQs of DBMS, each and every single question is being discussed in the special classes. And apart from that, I had taken the session on IP addressing. And DBMS is going on. In this, I had taken the sessions on theory of computation, compiler design, computer organization and architecture, and remaining other previous year questions. And on the plus, you can find my complete course on algorithms. Beta, यहाँ पे भी algorithms करवाया है, but this is not complete. All the applications are not covered. So complete course on algorithms is available on Plus. So this is the paid one. These sessions are free and special classes are also free. Apart from this, any query? So almost all the technical subjects I have covered, some on the Plus, some on YouTube, and some on the special classes. So you can refer to these sessions. So thank you so much guys. If you don't have any query, we'll end the class here. And I'll see you at 7 p.m. in the practice session on C programming and in the special class in which we will be discussing the previous year questions at 9 p.m. Till then, take care. Bye bye. God bless you all. And all the very best.